Let's solve numerical based on electric flux and Gauss's law. Here a question is designed for you. In this question, we have a uniform cylinder of radius 5 centimeter and length 20 centimeter. Let this cylinder is placed in a uniform electric field where the electric field E equals to 200 I cap Newton per Coulomb. This means that this electric field is towards positive x-axis. So I am writing here, this is the value of electric field. Here we have electric field toward this side, and the electric field E is equals to 200 I cap Newton per Coulomb. E equals to minus 200 I cap Newton per Coulomb for x less than 0. So this means that this side electric field E is equals to minus 200 I cap Newton per Coulomb. Now you have to find electric flux phi 1, this is the first surface, electric flux phi 2, this is the second surface, electric flux phi 3, this is the third surface, and total electric flux. This means that the sum of electric flux phi 1, phi 2 and phi 3. Then you have to find the charge cube inside the cylinder. Let us solve the question. So you know that we know electric flux phi is equals to E dot S, which means that you have E magnitude S magnitude into cos theta. This is the formula of electric flux. Now in the first part you require S for surface area. So first to calculate S, surface area S, this surface area, complete surface area is equals to pi r square. It is pi, what is r? R is 5 centimeter. So 5 into 10 to the power minus 2 whole square in meter. So this give you 25 pi 10 to the power minus 4 meter square. This is the value for surface area. Now part number A, you have to find flux phi 1. So flux phi 1 is equals to E magnitude S magnitude cos 0 degree, because this is the surface area S, and S and E both are having the same direction, so the angle is 0 degree. So put here E magnitude is 200 only. Put here S magnitude, which is 25 pi 10 to the power minus 4, and cos 0 degree is 1. Solve it. So 200 into 25 is 5000. Value of pi is 3.14 10 to the power minus 4. 10 to the power minus 4. Now multiply it. 5 into 4 20. 2 in hand. 5 into 1 5 plus 2 7. 5 into 3 15. Place this 1 2 3 0 here. 1 2 3 0. Now here when you remove the decimal sign, you have 10 to the power minus 2, 10 to the power minus 2, and 10 to the power minus 4 is 10 to the power minus 6. So move to 6 decimal point, 1, 2, 3, 4, 5, 6, give a point here. So you have 1.57, and the unit of electric flux is Newton meter square per Coulomb. So this is the electric flux phi 1. Let us solve the electric flux for the second surface. You are seeing that in this second surface, magnitude of electric flux in first surface is 200, and in second surface again 200, and it's have area along the same direction, which is S, and S is again pi r square into, here is I cap meter square. So both have the same direction, so again theta is equals to 0 degree. So when you talk about surface 2, that is case number B, in case number B, when you talk about case number B, surface 2, fortunately you get the same result. So you get the same result for surface 1 and surface 2. Now we are going to solve for surface 3. Surface 3 is this surface. So when you take this surface, here is the surface, this surface, then take a unit vector outside, then surface S is said to be lateral surface area, and electric field is in this direction, E electric field, or in this direction. If you take this electric field, it will be on RHS. If you take this electric field, it will be in LHS. In both the case, the angle between electric field and surface area is 90 degree. So, for you have case number third, phi number third, it is you have E magnitude, S magnitude, cos 90 degree. Cos 90 is 0, so you have E magnitude, S magnitude into 0, so this is 0. So we get electric flux in the three surfaces. Now let us solve it for part number D. That is, D part is you have to find phi total. Total electric flux is equals to phi 1, phi 2, phi 1, phi 2, phi 3. The values are, for phi 1 you have 1.57, phi 2 you have 1.57, and for third it is 0. So add it. 7 plus 7 4 14, 1 is here, 5 plus 5 10, and 1 is here, 1 1 2, and 1 is here. So you have 3.14. So 3.14 Newton meter square per coulomb, which you can either say, you can, this is also equals to pi Newton meter square per coulomb. Now we have to find the fourth part, that is total charge. So this part is solved by using the electric flux formula, and fourth part you have to use Gauss's theorem formula. So for fourth part, part number E, according to Gauss's law or theorem, flux phi total is equals to Q upon epsilon naught. So it is Q upon epsilon naught. Here we have the value of phi total. You know phi total is equals to pi. So here we can write like this. This is phi total on the LHS side multiplied by 4 pi epsilon naught. So you have 4 pi into Q, because 1 by 4 pi epsilon naught is 9 into 10 to the power 9. Now place the value. Phi total is pi, here put is pi. 1 by 4 pi epsilon naught is 9 into 10 to the power 9. You have 4 pi into Q. Now cancel the terms. So here this pi will be cancelled out. So you have Q is equals to 1 upon 36 into 10 to the power 9. So this is equals to 10 to the power minus 9 upon 36. So when you divide 1 by 36, so you have 1 upon 36, you have 0.02777 10 to the power minus 9, which you can write here 2.777. So 10 to the power, you are placing decimal point here, so minus 2 will be added here, so minus 11. And since 777 is recurring, so you can write it as 2.78. So you have phi total is equals to 2.78 10 to the power minus 11 Newton, not phi total. Here you have find it charge Q, sorry, you have a charge Q. Charge Q equals to 2.77 10 to the power minus 11. This means that charge Q is equals to 2.78 10 to the power minus 11 coulomb. This is the answer. Thus, you have understand how to solve numerical based on electric flux and Gauss's law. So do like, subscribe and share my channel. Physics Gold Ravi Kumar. Thank you.